Okay, thanks everyone, and thank you very much, Lindsay. Really glad to be able to do this webinar for you today. It's morning for me, but good afternoon or good evening to everybody else who's joined as well. So this webinar is going to be about why SQL injection does remain the #1 risk on the web today. And you'll see why it's classified as the #1 risk and how you exploit it, and also how to protect against it, which is kind of important when we're talking about SQL injection. So first of all, I am Troy Hunt. You can find me on Twitter @TroyHunt. I'm going to be live tweeting a bunch of links from this presentation today. If you've watched any of my courses or read some of my blogs, you may find some of it familiar. Other things are going to be from very, very recent events, even within the last couple of weeks. So I'll try and keep this as current and as relevant as possible. I'm going to try and aim for around about 30 to 40 minutes for this talk so that we've got heaps of time for questions as well, because I want everybody to make sure they can use this opportunity to ask me things directly. You'll also find a bunch of what I'm going to talk about at troyhunt.com. So there is a blog there, everything that you'd like to know about SQL injection but we're scared to ask, as well as, of course, a whole bunch of content on Pluralsight around about SQL injection. And just for some context on that, you'll find on Pluralsight now we have an ethical hacking series. And this ethical hacking series comprises of about 20 different courses, which you should be able to see on the screen in front of you right now. The ones with the green tick are done. So we've got a way to go, and I'm doing this in partnership with another author, Dale Meredith. So we've done the first 3 courses. He's done Introduction to Ethical Hacking and Footprinting and Reconnaissance, and I have done SQL Injection, which has now led to this webinar today. So you'll see a lot more courses come online over the remainder of this year. We hope to try and get it done pretty much by the end of the year. But certainly you can go and watch the ones with green ticks there now. So for those that are interested, you can go and do these courses one by one, and they're all sort of discrete atomic units, if you like. And also for those who are interested, if you would like to work towards your Certified Ethical Hacker certification from the EC Council, this is the good material that will help you learn what you need to know to get that cert. So with that said, let me go on and start having a look at what we're going to go through in this webinar. So a few different things. And #1, I want to talk about why SQL injection matters. So why is it such an important thing? And if you're in this webinar, you've probably got a bit of a sense of what might happen when SQL injection goes wrong, but we'll recap on that briefly anyway. We're also going to have a look at impact. So impact is really important. What does it mean when someone does suffer from a SQL injection attack? And as you'll see, the impact is usually about as bad as it can get. We're definitely going to go through the mechanics. So I'm going to show you some things in some slides about how SQL injection works. We're going to do some live demos in the browser. And you're also going to get a link to a sample vulnerable website that you can go away and practice SQL injection on yourself without going to jail as well, which is good. So there will be a place you can go and play. And finally, how to defend against it. So this is pretty important stuff. We want to make sure that not only people understand how to exploit SQL injection, but obviously how to protect others from exploiting your own things that might otherwise have SQL injection risks in it. So this is what we're going to cover. And again, we'll try and wrap up around about in the next half hour so that there's lots of time for questions. So do note down any questions that you might have, and we'll make sure that there's plenty of time at the end. If we run short of time for any questions, do get me on Twitter @TroyHunt, or you'll find a link to my email address on my blog under the great big email icon at the top of the screen. So feel free to email me as well. Okay, let's jump into it. And I want to start with why SQL injection matters. And I want to talk about 4 different things that are very important in understanding the significance of this risk. And the first one is discoverability. So it's really, really easy to find websites that have SQL injection risks. So I'm going to show you a Google Doc later on, so a Google search that finds websites that have a high probability of being at risk. But certainly locating vulnerable sites is easy. Now the prevalence is also very common. There's a lot of sites out there that have SQL injection risks. And you'll see that in part by how easy it is to find them with the Google Docs. And you'll also see it in relation to even some of the new things we're creating that have SQL injection risks. So you're going to see a lot about this sort of thing. Now exploitability is very easy, and you'll see just how easy it can be later on. So I want to talk about the actual mechanics and the underlying implementation, if you like, of a SQL injection attack. But I also want to show you how easy it is to automate, and the automatability of attacks is one of the really worrying things. And finally, the impact is severe, and it doesn't get much worse than an attacker getting access to all the data in your database. And what this means is that they can retrieve it, they can modify it. It also means, depending on the degree of severity of the attack, they might get full control over the machine. So they might literally get a shell on the machine. So they can execute arbitrary commands, they can pivot to other machines on the network. You can do pretty much anything once you own the machine on the network via an injection attack. Now, we're not going to get into too much detail on actually running system commands on the machine in this webinar today, but certainly that's something I do go into in my SQL Injection Ethical Hacking course on Pluralsight. So let's move on and talk for a moment about the impact of a successful attack. And there are three things that are really important to understand about a SQL injection attack. And one of them is confidentiality. So what we mean by this is that a successful attack gets data out of the database. So it impacts confidentiality in that internal, often sensitive data is disclosed. So things like passwords, for example. Now, incidentally, a successful SQL injection attack can even extract the password hashes of the actual SQL login accounts too. And this is another thing that I show in the full course. A bit too much detail for today, but confidentiality can extend quite a way. Integrity is another one. So integrity being that the data can be modified. So if an attacker can run arbitrary SQL commands on the database, then they can actually change the information in the system, which is obviously pretty nasty stuff. And finally, availability. Availability being that the attacker can knock the system offline. Or what if the attacker starts dropping tables from the database? If you no longer have your customer table, will things still work? Probably not, and you've probably got bigger problems than just stuff not working as well. So this confidentiality, integrity, and availability are the three attributes that you'll often find security and compliance people talking about. And they'll often use this in their risk assessments. And SQL injection scores pretty high on each one of those attributes. Now, another thing to understand with SQL injection is that it is a very, very high-rated risk in terms of resources like OWASP. So OWASP is the Open Web Application Security Project. And what you'll find about OWASP is they have this fantastic resource which is all about categorizing various web application risks. Now, there are a bunch of courses on OWASP on Pluralsight, and I'm just about to tweet you a link to those as well. So if anyone wants those, they can go and grab them from the tweet that I just sent now. So do have a look at OWASP, and what you'll see here is that OWASP is there in the top 10 in both 2010 and also in 2013. So SQL injection has been #1 for quite some time. We know about this risk. It is not a new thing, but it does remain at the top of that rating list. Now let's start talking about some examples of where SQL injection has gone wrong. And honestly, there are an almost limitless number of examples out there. So I thought I'd just pick one that's really, really recent. So there was this website, Ghana.com. It's a large Indian website. It has a very, very large number of users, and it's a music streaming site. And this did, unfortunately, suffer a SQL injection attack only a couple of weeks ago. And what we're seeing here is an individual who was actually quite creative. He found a SQL injection risk and then stood up a search page on his own site that exploited the SQL injection risk so that you could search for users in the database. And there are about 10 million users of this service. And as you may also see here on the screen, unfortunately they did things like stored passwords as MD5 hashes, which is an absolutely terrible way of storing passwords, but it is something that still happens. And what that consequently meant is that effectively that data had to be considered compromised. Now this is, I guess, the worrying thing. We're still seeing these attacks work. And this is not a sort of an old legacy site. This is a site that was stood up about 5 years ago. So it is something that keeps happening. Now what this guy did is he actually stood up this page which then showed, go to the next screen, which then showed this. So he had a nice little screen where you could actually search for people and find their information. And this is one of his test accounts. This is not someone's own personal sensitive data. The attacker was called MacMan. You can see that in the email address here. But it meant that you could pull this data out and just simply grab whatever you want out of the system. So this was a worrying case of SQL injection, and a very, very recent case. One other example before we start jumping into things is Drupal. And Drupal suffered a very serious SQL injection attack last year. And what I find particularly interesting about this SQL injection, and let's actually be clear, this wasn't so much a SQL injection attack against Drupal as it was identifying that there was a SQL injection risk in the Drupal framework. And the really interesting thing here is the bit in red down the bottom, where what Drupal has said is that if you are running this particular version of Drupal, and it was the current version of Drupal at the time, and you didn't apply the patch within 7 hours, you had to consider your site compromised. So it's like you go to bed, everything is fine, you get up maybe 8 hours later if you've had a good night's sleep, and now you have to consider your site compromised. So you didn't even have the time to patch it. And that's a very, very sort of forthright thing, if you like, for Drupal to say. And it's because SQL injection is such a critical thing. So let's start moving on and having a look at the attack. And I want to have a look at executing a SQL injection attack. I'm going to explain this in a very high-level way, and then we're going to move on and actually have a look at how to execute this firsthand. So we'll take a scenario. We have an attacker, and this attacker is going to make a request over to a web server, and then inevitably this site is going to form a SQL query. Now this is what websites do. This is the way websites operate, and that's just fine. You request a page. The page then needs to make a query to a database. Now often this query will pass through a firewall. And the reason I've put this in the diagram here is that the web application is usually externally facing, so we're talking about an internet web application here. And when that request is made, it goes through the firewall such that the database can be kept in a private network segment. So this is just good practice. Keep the database off the public network segment so that you can't connect to it directly. Doesn't always happen, but this is the ideal scenario. The point is that this query passes through the firewall and it's executed on the back end. Now inevitably the response then comes back through the firewall, back through the web server, and back out to the user. And the thing to understand about all of this is that the database is being connected to from the web application under an authenticated account. It's not normally the user's identity, it's normally one SQL login account, but the point is that the database has rights, or rather the application has rights over the SQL server. Now a couple of really interesting things here. The SQL injection attack is all about how the web application is creating the query. And what the attacker is really wanting to do is to get the web application to create a malicious query that's going to perform some sort of action that it's not intended to do. The significance of this authenticated piece down the bottom is that it all comes down to what the application is actually allowed to do to the database. So for example, is the application connecting to the database with an account which would allow it to drop tables? Because if it does that, then that would be an availability problem. Does the web application connect to the SQL database with an account which can run system commands on the operating system? Well, that might then be a problem where the attacker could traverse the network internally. So this does become a really serious issue just by exploiting the natural way that a web application works. And the point I want to make here as well is that it doesn't matter that there's a firewall in the middle as well. Because if that web application can create any query and throw it at the database, it's fantastic that you can't connect to the database directly from the public, but if you can run any command you'd like in there anyway, well then you kind of have a different problem. So let's move on and start actually looking at how we prepare a SQL injection attack. And I want to start with a URL, so something really basic like this, obviously just a sample URL. So let's assume we have a URL that has a path that has a query string. ID equals 1. Now, when someone goes to this URL in the web application, it will translate down into a SQL statement, something like this. Very, very basic, most simplistic example I could find. And that's fine. This is how web applications work. Now, if you change that URL, so the ID equals 2, well, then you end up with a SQL statement that looks for an ID being 2. Now, the significance of what I'm showing here is that there is this piece of data on the end of the URL which we can change and manipulate the query. This is also fine because this is the way the web is meant to work. You change the ID, you get a different widget out of the database. The problem comes when we start to manipulate that query string and get it to do things that it wasn't meant to do. So let me show you what I mean by that. Let's go and take another query and imagine that we ran a query like this, or rather we went to a URL like this. So what would happen to the query? Well, it would translate down into something like this. So let's have a look at what's going on here. We've changed the ID from 1 to 1 or 1 equals 1. Now this has really fundamentally changed the query because what's happening now is we've effectively negated the where clause because of course 1 does always equal 1. So now rather than just getting one product or rather one widget back from the database, we're going to get every widget. So in SQL injection, this is effectively applying a tautology. And a tautology is a statement which is always true. So by having a tautology on the end of this query, we've negated the where clause and we've changed the actual structure of the query. So this is no longer about changing the execution in terms of let's just get a different piece of data. It's actually changing the nature of the way the query runs. Now let's take that a step further. So what if we did this? So have a look at the query now. In the URL, we're seeing 1 and then a semicolon, and the semicolon terminates the SQL statement, and it allows us to append another SQL statement. So now we're seeing drop table widget at the end of this query string, which then means that once it translates down into SQL, we've really got 2 SQL statements. So we're going to get the widget where ID equals 1, and the web application will respond just fine to that, but then it's going to drop the table. And going back to that previous diagram, if the web application is connecting to the database with an account that has the rights to drop a table, we're going to lose our widget table. So that's a good example of how bad SQL injection can actually get. Now I'm just going to tweet out another link here for you, which is a link to my Everything You Want to Know About SQL Injection. And that is a free blog post that does explain all this. So you can get into more detail there. What I want to do though is I want to go on to the good stuff. So let's actually go on to the demos and start having a look at how these SQL injection attacks work. Now what you should be seeing in front of you now is a website at the URL hackyourselffirst.troyhunt.com. Now this is a website that I built in order to demonstrate some Pluralsight courses. So I have a course called Hack Yourself First, which is a very popular course because it runs through a bunch of really practical risks in web applications. Now this particular web application does have a lot of risks in it. It's got something like 50 different really bad security problems. And anyone can go there and have a play with them. Now I'm going to use this site to demonstrate SQL injection. So hopefully no one goes and actually messes up my database in the midst of this. Otherwise I'll have to very, very rapidly rebuild things. But let's jump into it before that happens. So here's what I want to do. I'm going to jump down the screen a little bit, and we can see I have top manufacturers. And I'm going to pick one of these manufacturers and just click on the View button. And what we're going to see now is in the URL we can see a query string. So we can see order by equals supercar ID. Now it's very easy to test for SQL injection risks in websites. And often it's just a matter of a single character. So if I jump up to the URL and just put a single quote, and hit enter, we can now see a problem. Now let's talk about what's going on here. We are seeing an internal exception, and in ASP.NET world, and this app is built on ASP.NET, runs in Azure. There's nothing wrong with ASP.NET or Azure, but you can still mess it up pretty bad, which is what I've intentionally done to this site. So we're seeing an internal ASP.NET exception, and this is what we colloquially call the yellow screen of death. So it has an internal exception message. We can see a stack trace down here towards the bottom of the screen, which has got everything that's happening inside the code, which should never be exposed to the user. Now the things we can see here that are kind of interesting, we can see an error here, unclosed quotation mark after the character string, and then we see a couple of quotes. And we can also see that the exception type is a SQL exception. So in other words, this is an exception that is being raised by the database itself, and it is now appearing in the web UI. Now I want to try and give you an example of what's going on here. And what I often do when I'm demonstrating SQL injection or teaching people how to use it is I'll open up a notepad window and we'll type out what we think is going on. Now have a look at this page. So this is selecting the makes, which is like the brand of the car. So in this case it was Nissan. And it's looking for the make, which is number 1, and it wants to order by supercar ID. So we're probably looking at a query like this. Actually, it will be select star from supercar, and then it would be where the make is equal to 1. And I'm typing behind a microphone as well, which is why my typing looks even worse than normal. Order by supercar ID. Okay, so that would probably be what the query looks like in the back of the database. Now we can surmise that this is what's happening and make some assumptions about it. So here's the thing, that last value there, the supercar ID, is probably what is being concatenated into the query. So it's probably going to look something like this. Now when we put a single quote on the end, and notice also that URL has now been URL encoded. So that single quote, Chrome has URL encoded into %27. So really we're seeing supercar ID, single quote. So it looks like this. Now when you look at this query in the notepad, you can see that if you were to run this in SQL Server Management Studio and try to execute it, we'd have a problem because we've got this quote just sitting out on the end. So this would not actually be a valid query. So this is why we're seeing things fail. We've got an invalid query, the database is telling us that, and it's returning that response to the user interface. So now what we can do is we can start to say, all right, well look, what if we actually toy around with this a little bit? What if we get the database to try and execute something else that might disclose another internal exception? So we know that the text I've just highlighted here in Notepad is what's being appended to the query. So supercar ID and the semiquote. So what if we did something like this? I'm going to take a cast statement. So a cast is going to try and cast one type to another type. And I'm going to call the system command, which is version, which gives us the database version. And I'm going to cast it as an int. Now version cannot cast as an int. So if I take this and I drop it into the query string and I execute it, we're now going to see the internal version of the database, which is the highlighted piece there. Because effectively what we've done is we've tried to cast this highlighted string as an integer, and clearly it's not an integer, and there's been an exception raised, and SQL Server has kindly returned that exception to the web application, and the web application has then told the users. So this is a really, really easy way of actually getting information out of the database itself. So let's move on. And what I want to do now is actually start to look at how we might get a piece of sensitive data out of the database. Now there's a lot of different ways to find the internal tables and columns and procedures and everything else about the structure of the database itself. And I talk about those in my courses. It comes down very often to doing things like actually selecting out of system tables. So you can grab data out of, let's say, sys.tables and sys.columns, which describes the entire schema. What I'm going to do now, though, is I'm going to change my order by clause here. And I keep coming back to Notepad because when you can see things in Notepad, it's much easier to actually construct your attack. So I'm going to do this. I'm going to have a bit of a nested query here. And I'm going to say select, and you do have to spell all this right too. Things will fail, but fortunately if I did spell it wrong, the database would tell me what I got wrong because the error is being returned to the web app. Now I'm going to cast password as an int, and I'm going to grab that password column from user profile. So when you have a look at this highlighted section just here, what I'm doing is I'm saying select the password, the very first password from the user profile table and try and cast it as an int. Now if that password is not an int, and we really do hope people aren't creating passwords that are integers, then that's going to cause a cast exception, and that exception will bubble up to the web app. So let's drop this into the query string and see what we get. And here we go. So we can see conversion failed when converting the nvarchar value password. That's password with a 0 instead of an O. Apparently it's safer if you do that. Don't do that. It really doesn't help. So we have actually got that password out of the system. And this is really important because it's showing that this is a piece of internal sensitive data which we have now been able to extract from the database. Now I'm just going to tweet the link of that website as well. So if people want to go and play with that, probably after this webinar when we're done with it, then that's great. Go and have a look at that. All right, now what we've just seen here is what we refer to as an error-based SQL injection attack. And it's called that because clearly we are seeing the internal error raised by the system. Now that's one style of attack. I want to go back to the home page, and this time what we might do is go and actually have a look at what we would call a union-based injection attack. And I want to show you what that looks like. If we scroll down the page a bit, we'll see we've got this section called cylinder layouts, and it's telling us how many vehicles have which sort of cylinder layout. So we might go to the 4 V12s, and what I'm going to do is copy a pre-prepared statement that I have over here in my clipboard, and I'm going to paste it into the URL over that existing query string parameter. So we can see another very typical sort of web kind of structure here where we've got cars by cylinder and then the query string name of cylinders and then the value of V12. So clearly we're seeing the V12s. I'm going to change that to this particular statement here. Before I press enter, we'll have a look at what's happening. We've still got V12s, and then we've got a single quote. So inevitably what is happening is when that original query string ran, it passes V12 as a string. So we're passing V12 again, and then we're putting a single quote to terminate that string, and then we're using a union clause. So remember in SQL Server, a union clause can be used to join two different queries together. They've got to have the same number of columns of the same data type, but again, you can discover all of that. And in the courses I go through in detail how you can actually discover it. So I'm going to union this second query. Select 0, and then a comma, name. I've got a collation statement in here because the collations of these two tables are different. And then I'm selecting from sys.tables. I'm finishing off with a dash dash, which is obviously the SQL syntax for a comment. So anything that might be appended after this data that's passed in via the web browser gets commented out. So let's run that. Now here's what we see. We had 3 cars here before. We've still got those 3 cars. Oh, sorry, 4 cars because we've got the Pagani, the Ferrari, the Aston Martin, and the Lamborghini. Now we've also got things like make, supercar, user profile. And what's actually happened here is as far as the web application is concerned, we've got one result set and it's trying to display it all to the page. But based on this query string that we just passed through, we've actually got not just all the supercars, but a list of all the tables as well. So now all those tables are being shown on the page. So this is really important because rather than the error-based injection attack where we've just gotten one piece of data by causing an exception, we've actually got the entire contents of a table that's been spat out onto the page. So this is pretty nasty, and it looks a little bit messy when it's on a page like this with all this other data as well. But the significance is we have got a list of data from the database, an internal table, a system table at that. And it's now all sitting here on the screen, and we can see what that internal implementation is. So union-based attacks are very, very significant in that it doesn't matter that you're showing internal exceptions on the web page because you're getting all the data back as part of the result set anyway. So let's move on, and I want to show a little bit of automation because as cool or perhaps as scary as this is, there is obviously some manual construction that goes on. So here's what I want to do. I'm just going to jump back a couple of spots. And what I will do is let's go back into the Nissens. I'm going to copy the URL from the clipboard. And now what I'm going to do is I'm going to open up a little tool called Havoc. Now I use Havoc in a lot of my demos because it is such a simple tool. I've got a video of me teaching my 3-year-old how to use Havoc. I do it in a lot of my talks as well, and I get someone from the audience to use it. Someone who's never done any SQL injection before because it is so simple. Now here's what I'm going to do. In this target field at the top, I'm going to paste the URL, and I'm going to click the Analyze button. Now what's happening is Havoc is going and automating the process that we just performed ourselves. So it's actually trying to send different input to the system to try and get it to cause an exception which discloses internal data. And we can see right down the bottom of the screen, it says DB name hackyourselffirst_DB. That is the internal database name of this system. So it's already getting data out of the system. We're now going to go to the Tables button, and I'm going to click Get Tables. And what's happening now is Havoc is sending HTTP requests to the database, and it's finding all of the internal tables. So this is what you see on the left-hand side of the screen. So we can see web pages, membership roles, users and roles. All of this stuff is actually the same stuff that we just saw in the union-based attack, but it's Havoc automating it. We're going to get user profile, and we're going to get the columns in user profile. And Havoc goes away again and issues HTTP requests, and it finds every column that is in that table. Now when this runs, we're going to decide what columns we would like to exfiltrate from the database. Now I would like to get email and password and get data. And again, Havoc goes away and starts making requests. So these are all of the users in the database. There's their email addresses and there's their passwords. And I'm showing you this because it is such a trivial, basic tool. Now there are other tools out there on the web that frankly are even better at getting data out of the database. So I'm just tweeting one here which is SQL Map. And SQL Map is a very powerful tool. It is command line based, so it doesn't look quite as trivial in demos. But if you're serious about actually testing SQL injection in your apps and seeing what can be done with it, a tool like SQL Map is very powerful. Now I showed both SQL Map and Havoc in a lot more detail in my ethical hacking course on SQL injection. You will find that Havoc in particular has now disappeared. It has been removed. In fact, the whole organization that hosted it appears to have been removed. If you want Havoc, send me an email. I do have my own copy of that. It is freeware, so it was never a commercial thing anyway. Again, email address on my blog under the big email icon. Okay, so that is how easy it is to find and exploit SQL injection risks. A couple more things I want to look at very quickly. So one of them is it's very easy to find SQL injection risks via a Google Doc. So a Google Doc is something like this. Now what I've got in my URL is a search for any resources that have .asp in the URL, so .asp being the classic ASP, so this is the pre-ASP.NET implementation. So we're now talking about a technology that we superseded about 15 years ago. So it's mostly old stuff. It's mostly stuff where people didn't really have a good grip on risks like SQL injection. And I want something that has an ID equals in the query string. And we've got some 250,000+ results here. Now clearly I'm not going to go through these and start checking if they have SQL injection risks. But what I can say is that a significant portion of them, as compared to the web overall, do have risks. Now one of the things that's significant about a search like this is that this is what we see attackers doing. So there was one just recently actually where this kid, we know he's a kid because he's since been arrested, was just Googling around the net looking for risks like this. He'd go and he'd copy one of these URLs, he'd put it in a tool like Havoc or SQL Map, and then he'd say, okay, well, now do we have your data? And every now and then he'd get a hit. And again, it was a pretty successful hit rate looking for stuff like ASP. Looking for Cold Fusion.cfm is another one that seems to be quite popular. So kids will just Google around, they'll find these risks, and they'll throw them at an automated tool, and then they'll see what happens. One more thing, and then we'll go and we'll talk about defending. There are also resources like PunkSpider. And PunkSpider is very good for actually searching for websites with risks. So for example, we could say we would like to search for anything with the word bank in the URL. We'd like to search for banks with SQL injection risk. Now please go and find them. And what will happen is PunkSpider will go away and give you a list of websites that it has indexed with SQL injection risks. We can see those appearing down below. We can see that some of them have not just SQL injection, but also XSS and other things as well. So the discoverability of sites with SQL injection risks is massively high. So I'm conscious of time, and I do want to make sure we have time for questions. So I want to go on and talk a little bit about identifying vulnerable code and how we can defend against it. I am also just going to share both the link for the Google Doc, in case people want to have a look at that. So that one is now there on the tweets. And I'm going to share PunkSpider as well so that you can have a look at that and be amazed at the sorts of things that are indexed and readily searchable. All right, so moving on. Let's have a look at how we defend. So we're going to start by talking about the vulnerable pattern of code. Now the code I'm going to show here is in C#. It's in an ASP.NET application, but the same concepts apply to other technology stacks as well. And it basically looks like this. So we're going to get from the query string the ID value. So imagine this is our typical selector widget where the ID equals 1. So we're getting the ID query string value. We're then constructing a SQL string. And what you can see here is that we're appending the ID to the existing statement. And then the whole thing gets executed. So what happens from line 3 down doesn't matter too much other than to say that it is actually executing the query in the database. Now the problem here, of course, is that after line 2, we've just got one SQL string. So you can pass whatever you like as ID. So you could pass a 1 or a 2 or anything like that, and that's obviously fine. But you could pass the tautology, so the or 1 equals 1, or you could just terminate the statement and add something else. So anything that you pass in the ID value will be appended to the query string and then goes into the SQL statement and is executed in the database. So here's the first thing that we can do to fix this problem, and it's validating untrusted data. So untrusted data being anything that comes via an externality on the web. So query strings, form data, request headers. You can have SQL injection attacks in request headers. Now it's very simple what we're going to do here. We're going to create an ID int integer type, and then we're going to try and parse that query string. So what's happening here is we're saying, hey, the query string must be an integer. And if the query string is not an integer, we're going to throw an exception. Now this is really simple. So we can make this ensure that that untrusted data adheres to the expected pattern. Now of course the expected pattern is not always going to be an integer. The expected pattern may be it has to be an email address. And clearly we could validate an email address via a regex, very, very carefully via a regex, because email addresses are notoriously bad to parse. But something like if it's a URL, you could validate it. If you're expecting a known set of values, so think about that order by clause before, we could whitelist them. So what I mean by that is we could say you can order by supercar ID, maybe the power and the top speed, but if there's any other value, then we're going to throw an exception and we're not going to process any further. The whole idea of all of this is to try and validate the data before you do anything with it. And that's good practice not just for SQL injection, but for things like XSS as well. Okay, so here is the next thing, and this is really the heart of defending against SQL injection attacks, and it's parameterizing your queries. So let's take the first statement again. That's fine. Let's take in that ID. And what we'll do now is we'll define a constant, which is the SQL string. So this is really important. The query looks very similar to before, but what you'll see is that when we say where ID equals, rather than just appending that untrusted data, we're using this at syntax. So where ID equals at ID. And this whole thing is a constant. You will not be able to change this string. What we're going to do though is we're then going to go down and we're going to create a new SQL command. So this was the same as before, but the really important bit is on that command we're going to add a SQL parameter. And you can see that second last line from the bottom is creating a new parameter. It's calling it ID, so that will match up with the @ID in that SQL string on the second line. It's passing a type, SQL type.int. So it's actually going to validate that this is an integer as well. And really, you should still be doing what we saw on the previous screen, the whitelisting of the untrusted data. But it's going to make sure that it's an int, and it's going to pass that in as a SQL parameter. And then it's going to open that connection. So this is good because what it means is that you can never break out of the actual data context and enter the query context. So no matter what you pass as ID, it will always be looking at that as a piece of data. You can't actually change the execution of the query. Now ID, or rather integers, are always a little bit trivial because it's very, very easy just to make sure that something is an integer. But this sort of thing is really, really critical for things like strings. So what if you had to accept any string at all from someone in a web application? So for example, when you're taking someone's name in a web application, it's very hard to say you're not allowed to have certain characters in a name because it's very easy to mess it up. And certainly there are many well-documented cases of Irish people not being able to register on websites because they tend to have a lot of single quotes in their surnames. So parameterization, absolutely key. The final one here is principle of least privilege. And what we're really saying here is that when the database talks to the web app, or rather when the web app makes the request to the database, let's make sure it's using an account that only has the absolute bare minimum of permissions. So what we're seeing here is the permissions on the widget table in the database. And I want to make sure that people remember that what you don't want to do is just give the web account access to everything. So for example, I see a lot of cases where the web application connects to the database using the SA account. Server admin, it can do anything. You want to watch out for that. In fact, there are Google Docs you can do that will disclose the web.configs that are publicly facing in websites. It happens, believe it or not. And you can see a bunch of them are connecting with SA. Or they're connecting with accounts that have DBO, because it's very easy to manage permissions on a website when the account can do anything. What you want to do though is filter this down so that you're providing permissions on either a per table level or all the way down to a per column level. Either this or you're providing privileges on things like stored procedures, because stored procedures are coded to do very, very discrete things. What we're trying to do is, wherever possible, avoid just the blanket set of permissions where we say the web application can do whatever it wants to the database. This is certainly not foolproof, because you're still going to be able to, or rather you're still going to need the web application to be able to talk to various tables and columns in the database legitimately, which you may not want being returned to the user interface. So this is one of those things that happens in conjunction with whitelisting of untrusted data and parameterization of queries. Now the last thing I want to show is this. Now this is, as you would now know, vulnerable to SQL injection. So we can see that the statement is just simply being concatenated. And what's actually happening here is we are going to have a SQL injection problem because it's just getting the text value from TXT email and it's executing it. I'm showing this because this is in a tutorial that was written this year about how to write a password reset feature. So this is a public blog post, and you could probably Google it by looking for the strings that are on the screen here. But this is kind of the worrying thing, because people say, why is SQL injection still a thing? Like, haven't we actually fixed this by now? And the concern is that we're not only still writing new code that's vulnerable, we're teaching other people how to do it. So again, this is a live tutorial that was written this year about how to write code. And this is why SQL injection is still in the #1 spot. So I'm conscious of time. We have about 15 minutes left, and I'd like to try and leave a little bit of time for questions. So I'm going to just jump over into my questions tab here on my other screen and have a look at what people are asking. And Lindsay is kindly curating these for me. So we've got a question here from Jake Roberts. Question for Troy. How would an attacker go about cracking MD5 hashed passwords? So the way you would crack an MD5 hashed password, first of all, if you want to have a look at this, it is in my Pluralsight course on Hack Yourself First. But in short, MD5 is a one-way deterministic hash function. So you can hash a string, say password with a 0, and you will get a cipher out the other side. And then every time you hash that same string again, you get the same cipher, the same result. So one really, really easy way of cracking this would be to get the cipher. So you go to the database, you get the MD5 string, and you Google it. And if you Google it, you will find results that tell you the plain text version, because there is a huge index on Google of all of these hashes and their plain text equivalents, which is why we started using salts to add randomness. And it's also why things like a salted SHA-1 password are pretty useless now, because it is so fast to recompute them. If you want to find out more about this, and I'm going to try and give people resources, search for Troy Hunt's hashing no close. And I know that that sounds really weird, but it's because the title of the blog post is Our Hashing Has No Close. So if you go and have a read of this blog post, it will explain exactly what the problem is. So I want to move on to more questions. We've got one from Nimal. Question 1, if the web page uses authentication, how to use Havoc? Havoc won't do you much good for that. Havoc is a very, very basic tool. Have a look at something like SQL Map, excuse me, which from memory allows you to add in authentication data. Second one, how to use Havoc for a post request. Again, basic tool. Look at SQL Map instead. Look, I show Havoc because it is such a simple, trivial GUI-based tool that it's a very good demonstration of how easy SQL injection attacks are. If you're serious about it, though, go and use SQL Map. That is the tool of choice for SQL injection these days. I'm going to keep reading these questions. Feel free to keep asking them as well. Where do I send requests for tool Havoc? Again, on my blog post, there's a great big email link. Send me an email. I'm just not sort of publicly sharing a link simply because I don't want to sort of publicly redistribute someone else's software. But they have disappeared offline. It looks like they're completely gone, and it is the free version that was publicly available. Send me an email, or frankly, do look at SQL Map, because if you're serious about actual exploiting of, I assume, your own system as well. So let's be clear about this. Don't go and Google for other people's systems and then point SQL Map at it. That tends not to end well for people that do that. But do go and use SQL Map if you're ethically hacking your own things. Another question here. Some web frameworks only escape the parameters, don't bind them as parameters. Do you know any way to bypass escaping? So I think what you're saying here is they're looking at the untrusted data that's coming, say, via the query string, and they're saying, let us just escape this so that we can still concatenate the string, but hopefully it doesn't break out of the query context. In my ethical hacking course, there's a lot on bypassing defenses for SQL injection. It talks a lot about escaping. So can we, for example, use SQL escape sequences that bypass the input validation but will still execute when they hit the database? So there's a lot of information in that course. Otherwise, if you Google for SQL injection bypass, you'll find a lot of examples as well. All right, another one here. What are your views or even row-based access controls when placed in context regarding maintainability? So I think what we're saying here is a row-based access control where the account that the web application is using can only access certain rows. Look, anything that filters down the potential risk or scope of an injection attack, or any sort of attack for that matter, is a good thing. As you've said, there is the question of maintainability. So does the web application have a good native construct to be able to filter down to rows, or is it going to create a nightmare for maintainability? That is really a case-by-case decision. I think for the most part, if you get validating untrusted data right and you get parameterization right, they're the two biggies, parameterization in particular. Row-based access controls can give you some other defenses as well, such as if you had, say, a direct object reference risk where you change an ID in the URL and you get someone else's record. It could help with that sort of thing too. But defense in depth. So apply these defenses in layers. Another question, does parameterization entries cover the SQL injection risk? This is the developer would not have to worry about data validation. So parameterization should be the one thing that really does nail all SQL injection risks. If you parameterize, you should no longer have a risk. That doesn't mean that you shouldn't do the other things though, because the one time you forget to parameterize or you have a weakness in the way you've done the parameterization, then you're going to be looking at something else to save you. And I guess the point here is that we talk a lot about defense in depth. So how can we apply layer upon layer of defense such that if we get one thing wrong, or if we later find that there's a vulnerability or a zero-day risk in another part of the application where we have a defense, that we don't just have this single point of failure. So try and do multiple things. Another one here, is there any pros and cons from a security point of view in using ORM systems like Entity Framework? So things like Entity Framework are fantastic for protecting yourself against injection risks because you're not writing any SQL, and Entity Framework itself is actually doing the construction of the SQL query. Now what I will say is that you can still have SQL injection risks in Entity Framework, and you can still have SQL injection risks in query strings. And if you look for Troy Hunt's SQL injection stored procedure, you'll see a blog post that I've done on this where it says stored procedures and ORMs won't save you from SQL injection. So you can still have risks, but they do make things much, much better. You have to use an ORM like Entity Framework in a very bad way to have a SQL injection risk. So yes, they're good defenses. Will the SQL injection only occur when you're working query strings, or can it happen otherwise? It can happen otherwise. So it happens when you have untrusted data. So query strings are a very easy way of demonstrating that. You can have untrusted data in the form. You can have untrusted data in the request header. In fact, Reddit don't do this anymore, but Reddit used to set their server header, so this is actually the response header, to a SQL injection attack. So you'd go to Reddit and their server in the response header was something like drop table server or some sort of SQL injection pattern. Now I don't know how many people actually got caught by that because it's quite an obscure one, but the point is that a SQL injection risk can come anywhere that you're accepting data from an externality that you can't trust. So query string, form data, request headers, even if you're pulling data from a website somewhere. We've seen a lot of attacks over the years in things like DNS records. So in fact, I was looking at one just this weekend where DNS records were having persistent XSS risks because people were setting the text records on their DNS to XSS attacks. And because the websites weren't then properly encoding it, when you actually did a whois on the DNS record, you could execute the XSS risk. So that sort of thing happens a lot. Can you trust the web server from showing SQL exceptions? So one thing that you must do, and in fact I probably should have mentioned it as well, is make sure that you do not show internal exceptions. So you should never see the internal exception in the web interface. And a framework like ASP.NET has easy constructs to keep your internal things internal. So it has custom errors. Yeah, always turn custom errors on. Never show the internal exception. That will not save you from SQL injection though. And in my ethical hacking course on SQL injection, I talk a lot about blind SQL injection. So what happens when you can't see an exception with error-based injection, and what happens when you can't use union-based injection as well, but you can still modify the actual SQL query. So that's blind injection, and in the course I talk about Boolean-based blind injection and time-based blind injection as well. So just keeping the errors away won't solve the problem. Another question, how much do you rely on automated tools like SQL Map Havage compared to the manual attempts? So look, again, Havage is something that I probably wouldn't use very much other than demos because they're impactful demos. I would use SQL Map more often. But for me personally, whenever I build anything now, I use Entity Framework. And it goes to the point before where when you build something with Entity Framework or any good ORM, you're going to have everything looked after in terms of parameterizing queries. I guess, first of all, I don't worry too much about SQL injection in my own thing these days because you're secure by default with a framework like that. I tend to use automation more on a more holistic basis, so I use things like NetSparker. And what I mean by holistic is you point it at a URL and it looks for SQL injection and cross-site scripting and exposed directories and all sorts of things. So I like automated tools. And again, I talk a lot about automated tools in the ethical hacking course. I find that's a much more sort of comprehensive way of looking at things. But again, look, I mean, no one should be building applications at risk of SQL injection if you're using a modern framework like ASP.NET and a modern ORM. So that worries me less in my own things. It worries me more about other people's things. Do you think enough security is taught on undergrad software courses? No. I think it's probably pretty self-evident by now that we do have some serious security problems in the industry. Often security is implicit. And what I mean by that is that it's implied in requirements, so it's not called out in terms of these are our security expectations or controls. I think it's implied in a lot of teachings. And as I showed you before, often we're seeing teachings about a topic which may actually have very serious security risks in it because the people teaching don't even understand them. So I definitely believe that we need to do a lot more in terms of whether it be undergraduate or secondary school or wherever people are learning about coding, learning about what the secure patterns are. Now, one of the things I do a lot of, particularly in my Pluralsight courses and my in-person workshops, is I show developers how to break things. And we saw a little bit of that today as well, because I think when you teach people how to break things, they get much more engaged in the process. In my experience, developers actually quite like breaking things. It's a bit of fun, and they build more secure code as a result when they know how to exploit it. Question for Troy, can you comment on PHP-based SQL attacks, SQL injection attacks, I assume? Same sort of thing. Look, really everything that we've looked at today is not specific to ASP.NET. It's the same attack patterns against different frameworks. The main thing that changes with different frameworks is the underlying database. So if you have PHP talking to MySQL, there are differences in the syntax semantics of MySQL than what there are SQL Server. So if you wanted to just take the top number of records rather than the top 5 records in SQL Server, it's going to be a limit of 5 in MySQL. Now, good tools like SQL Map will identify the underlying database version, and we saw in that error-based example earlier on how to find the database version, and then they'll tailor the attack for that database version. So yeah, that will really, it'll depend on the tool, but most of them will actually look for that version. Question from Chris McNeil, when performing manual SQL injection attempts, how much do you persist? When do you decide that the site is safe versus it simply filters some common words? So I'm always a little bit cautious about ever saying that something is safe or secure as though it is some sort of absolute state. And I think it's really just a question of degree. So I think what Chris is saying is how much effort do you put into it? One of the things that's probably worth thinking about is whether you're doing dynamic analysis, so you are remote and you can see the web application externally but you can't see the internals, or whether you're doing static analysis and you have the code. Because if you have the code, you can have a pretty high degree of certainty that it's not going to have an injection risk if you can see how the queries are constructed. Remotely, you're going to have to make a case-by-case decision. So how many different inputs do I look at? So which functions of the web application do I look at, and how many different variations do I try? I find that the automated tools, so things like SQL Map, are very good because they'll go through and they'll try a whole bunch of different attack patterns themselves. One thing to keep in mind is that most of what we did with SQL injection just before is repeatable and automatable. So it's a very sort of well-known set of attack patterns. And when things are repeatable, then it is very easy to actually point a tool at them. So me in my human capacity would probably not go too far, at least not as an initial identification of risk. Perhaps if the tools pointed that you are getting unhandled exceptions on a resource, then I might try manually exploiting that a bit further, but I'll definitely start with the tools. I'm conscious of the time. I'm going to keep answering questions. I can see about another 4 questions here. So I've got time, if you guys have got time, so let me go on answering it. And Lindsay, feel free to interrupt me if you need to
I think that's fine if you want to hit the last question. We have time.
Okay, well let's keep going then. So Mark's got a question here. So it's custom error pages all the way. In terms of keeping internal exceptions out of the public eye, yes, custom error pages are a very good idea. It's not just SQL injection as well. So by exposing internal implementation data, you might see lines of code, which is what you do see in an ASP.NET app when you don't have custom errors on. You might see the paths things are executing in. You might see internal frameworks. And these things can be used to find other risks in the web application. So you definitely don't want to be showing internal exceptions, not just for security, but it's not a very nice usability experience for a user to see a yellow screen of death as well. So yes, it is custom errors all the way. Gary says, I know Dapper uses parameterized data, but that doesn't save you from string data, right? So Dapper being an ORM, a micro ORM from memory, will almost, and I'm saying this not having actually used it, but if it is an ORM where you can actually construct, say, a link-based query which then gets translated into a TSQL-based query, then yes, it should, but I actually have a bit of a feeling Dapper may allow you to construct your own SQL as well. So I might need to get back to you on that one, Gary, so do ping me offline if you still want clarification on that. But what I do know is the guys that built it are certainly aware of the thing that is SQL injection. One from David, just a clarification, if a string parameterized, should it be escaped in some way? If you're parameterizing, you won't need to escape. And just to clarify, I think what David's getting at here is, for example, if there was a single quote passed, should the web application escape that single quote such that it's not used to terminate a string in SQL and it just gets parsed as, as a string when it hits the database? You want to try and avoid this kind of manual escaping, not just because you have to get all your escaping right, but because at some point you've got to unescape as well. So by adding it as a parameter, it will always be considered as an atomic unit. So it won't actually break out of the data context, so it won't stop being a one or its own self-contained string, and it won't break into the query context, which is that it won't start to modify the query itself. So you shouldn't have to worry about escaping if you are doing input validation and you're doing parameterization. One from Duran, question, as an undergrad, how would I improve my understanding of security as a whole? Well, you go and watch Pluralsight courses. That would be a good start. But in all seriousness, that is obviously one avenue. Another avenue is there's some really interesting people to follow on Twitter. So people that I would recommend are people like Mikko Hyppinen, who's the CRO of F-Secure, people like Brian Krebs, a journalist who writes some absolutely fascinating things. He has a column called Krebs on Security. Someone like Jeremiah Grossman from White Hat Security as well is also very, very interesting. So there's a bunch of really, really smart people out there. Bruce Schneier, a cryptographer, is another one. If you want to be totally confused and realize how little you know, and I include myself in this when it comes to cryptography, go and follow Bruce Schneier as well. So, Lindsay, are there any other questions that you want to put forward?
No, Troy, I think that's all the time we have for questions today. Do you have any closing remarks?
Oh, look, I think the closing things are, if you want to ask me any questions, you can get me on Twitter at Troy Hunt, and I can see I've had a lot of tweets that I'll go back through after I finish this call. Again, on my blog, troyhunt.com, which you see in front of you, you can see an email icon up the top right there, so you can get in touch with me via email as well. And look, that is about it. If you think of anything else later on, please get in touch with me. You know where to find me. So thank you very much, everyone, for joining, and also Lindsay for facilitating the webinar.
Thank you, Troy, and thank you, everyone, for attending. Thanks for your participation and your questions. If you have additional comments or feedback on the webinar, please feel free to email us at webinars@pluralsight.com. This webinar was recorded, and we'll email you the link in just a few days. Remember to tweet about your experience today and continue the conversation with Troy with hashtag PluralsightLive. And remember, as you leave, please fill out our survey. Thank you again. Have a wonderful day.